Hello, we're here with another coding stream. Oh baby, who knows? Who knows what could happen? Who knows? JavaScript, I mean not Java. Java what? How did Java happen in a coding stream? That's crazy. Hold on, I'm gonna wipe off this. There's a bit of chocolate on my little pop filter. So, when we last left off, it was a bit confusing, which, well, one, it was a while ago, but two, it was a bit confusing, wasn't it? Huh. It's a bit warm in here, actually, so I'm going to make you wait a little more. I'm going to go put on a little, well, I'm going to turn on the fan, but also put on some pajamas. So, actually, back to waiting. Haha, sorry. All right. So, where we last left off with this, we were trying to discuss, the sense thing, right? How to get the sense to work. Difficult. Not difficult anymore. So here's some changes that I made. First off, the spawner thread, I've completely reworked. It is now, it's not abstract, but it extends, it has a generic it infers a generic type of a game object. And then we just have the list set on whatever the type is. There's that, add object, remove object, get all objects. Cool. And then we have, so this happens synchronous, so we make sure there's no, oh, nice. So we don't have any, the problem with just using lists in main, which as you can see here, I added them all like this, and it is basically just a fancy list. But the nice thing is this refers to a different kind of list, gives different kinds of lists. It's stuff that you'd have to do in this way. I've tested it. But we also have get all objects here in main, and then here we reworked the whole main thing, added these starts, made sure to refer to cell spawner and tree spawner. I went through all the other objects that had issues and changed them to use cell spawners, fruit spawners, and tree spawners, respectively. I changed this to work that way as well. Basically, have the same build here. Also, we make sure to set the color once, and then you can just draw all the objects. And then, in Sense, I kind of put it back to where it was before we started making any of these crazy changes. Why we were making these crazy changes, I don't remember. But we'll discover as I start working with the cell again, which I also fixed. So now, here's the, oh, whoops, I ran the wrong thing. Now, we'll right-click on this and do run as Java application. So now let's make sure everything is correct. We only made one cell, if I remember right, and then all the trees. He's just wandering around, dying casually. Poor boy. I also want to change the fruit lifetime. In seconds, 16 seconds is how long they last. I'm cool with that. Okay, so we're going to go back here, set the cell count to, nice, 500. Boom, so everything still works as it should. We're going to go and set it back to 100. And now, here we go. There's some things we could try. I could always try making sensors that are specific, a sensor that is specific to certain objects. Or alternatively, I could create just those methods in the sense and have them sense certain things, since we're going to want to sense cells fairly often if we're looking for cells. Basically, I don't want it to update too often. But what we will do is we are... Okay, yeah, so I remember while I was doing this. You want to sense certain objects at certain times, right? So you do update. We're going to add, okay, I know what to do. We're going to call this, oh, nice. We're going to call this update, right? Update is just going to be a generic update. We are going to add other updates based on different kinds of objects. Update. Actually, we'll think here for a second. Back to the not the drawing board, but something like that. Okay, maybe, so here's the thought. We can create multiple sense, like an abstract sense class that makes sense like an infer generic type as well. Or I think alternatively, we'll just create the methods. So we'll create another public void update. But instead of update, it's going to be update fruits, update cells. Trees we're never really going to want to sense. So update cells is going to be main.cellSpawner.get all objects. And then this one doesn't need to remove the cell. It is just going to do main.fruitSpawner.get all objects. Weak to a power like this. What was it? A woman. What? Go inside. Okay. So we're going to have cells and fruits separate. But we're not going to have them in separate lists. So you're only going to be checking for fruits or cells once, right? Okay. So now that we have this, we're going to go back to cell. And we're going to do update this. So we'll do a full update. At some point we might have it to where cells will look for other cells to maybe run away from or try and eat if we want to make them destructive to each other. Again, this almost makes me want to make sensors for generic argument types. Let's think here. Okay, sensor. What we can do here is have separate sensors. So we're going to have a fruit sensor. Fruit sensor, wow. Fruit sensor. So we're going to have a fruit sensor. Specifically, and we'll make a cell sensor if we need to. Oh, what the heck. Let's just call it sensor for now. Update fruits. Let's just update fruits. So now, if it's not empty, we're going to go over there. Otherwise, we will wander. So let's see. They all should go around until they find a fruit. There we go. So one over here is just going to the fruit, and then they all die, which is fine. So now we gotta check if it's in collision with a fruit. We'll put this in. We're not gonna make this to do anymore because we're doing it. If, here we go. So we're gonna do an if statement. If sensor dot get closest this dot get center, I believe. Get closest dot get center dot is within this dot get center this dot gets get W. So this should system. We're gonna do. Here's what we're gonna do. We will set this dot. Well, no, we'll do hunger equals max hunger. There we go. Hunger equals max hunger, and then there is a way, if I'm correct, to set a variable, right? If fruit yeah, we'll go if fruit So I know there's a way. Let me look at this real quick. We're gonna do creating a variable in if statement. If I can type Java. Assign variable inside if statement. Cool. Can be assigned but not declared. If v equals some method. Okay, actually, that's a good point. We're just gonna do. Oh wait, it's we already have a target. What's wrong with me? If target dot get center, we're doing target get closest to the center. We're getting the position. Getting center. If target dot get center. Oh, target is the XY. Interesting. Getting closest returns. Oh, it should return the game object. So first off, I don't think we need to do this dot target. We're just gonna do target. And I've been using this way too much. If so, target is that. So we're actually going to create sensor.update fruits. And we're going to do a game object. We're going to call it closest equals sensor.getClosest. This dot get center dot get. Well, actually, that's all we need to do. The closest to the center. And this is going to equal closest dot get center. Then this will be closest. Man, I can't type today. This is weird. So if closest dot get center is within that, and then we're going to do close. Well, we'll do main dot fruit spawner dot remove object closest. And we're just gonna make it a fruit. Who are we kidding? And we're gonna cast it to a fruit because we know we're updating fruits, right? Well, at that point, we're gonna just fruit closest. Still up import fruits. Let's see how this works. Oh, well, everything broke. So sensor update fruits. if sensor if sensor is not empty, we're gonna put this over here. And then it's gonna be the center of the closest. There we go. One of these should go for the fruit. There we go. Trying to get width -2. Oh, they're having some trouble here. Why are they having some trouble here? The target is, oh, I guess it has to get position, not center, because we're going to a position, not a center. Width divided by 2. Let's try that. There we go. Although, oh, they still think it exists. Oh, well, they all died. So they still think that the fruit exists. Even though we're moving the object, so fruit almost has to... Actually, we'll do this in a game object, unless I already have it somewhere. We're gonna do public void destroy. Okay, the problem with destroying is now we have to do it based on whatever object it is. Oh. Now hold on just one moment. I will return shortly.
You don't wanna keep on swimming in the ocean of pride, but I won't let you drown. I'll pull you back to the shallow. 'Cause all I ever really wanted in this short life was you. Tell me who took your heart away, and do you know it breaks mine when I hear you say that you're done with love. Oh, you were done with love. Oh, give me
I return from the Shadow Realm. Ooh, I like this song. Let me give us a little more volume there. Okay. So, where were we? Destroy. That's right. That one's a little more problematic. Because we have to check... public abstract void. Destroy. Boom. There we go. So now all three of these need a new implementation. We're going to add it above here. Destroy. We're going to do main dot cell spawner dot remove object. This. And we're going to do the same thing to the rest. To the fruit. We'll toss it on the bottom here. We'll do the fruit spawner. And then the tree. Same thing down here, but do the tree spawner. There we go. So now in cell, we're going to go down here, and instead of doing this, we're going to do closest dot destroy. There we go. Then we got to make sure that we don't... Well, let's hope this works, because there's a chance that the garbage collection isn't collecting the garbage. Well... Boing, boing, boing. Come on, buddy. So it's like they're... Update fruits if the sensor is not empty. But then if the sensor is empty, we're going to wander. Oh, but the other thing we need to do is sensor not empty. Well, the sensor is going to remove anything that isn't in range. Oops. Okay, we're going to create a single cell again, and we're going to do a little testing here. We're going to do system.out.println. Sensor is not empty. Let's see if he's near a tree. Okay, so he should survive if he wanders the right way. Buddy. Buddy, you're gonna die, buddy. Buddy, no! Alright, we're gonna try this again. He's definitely gonna die. Yeah. Hold on just a moment. I'm gonna respond to a message. Alright. So, let's try this again. Not gonna live. Try this again. He's definitely not gonna live unless he wanders just the right way and goes fast enough. Come on, buddy. You got this. Buddy, no. Buddy, come on. It's right there. Oh, okay. Promising. Promising. Oh, no. Go other way, man. Other way. Come on. Oh, you're almost there. No. A little bit more. A little bit. Oh, no. He was so close. He was set up for greatness, and wow. Okay, here's what we'll do. We'll create 5 cells. That will create 10. I just don't want to accidentally have to keep track of a bunch. He's just scooting along there. Okay. Sensor is not empty. Else break. Maybe not break. Let's think here. Grid line. Closest. To string. There's no way he's missing that. Oh, your sight isn't that short, man. And your reaction time isn't that bad. Wow, they all missed it. This guy can't. Okay, he should be the only one who survives. Weird. So else wander. Wandering. Let's do this with 1 cell again, and let's create 18 trees. There's no way. Oh my gosh. Okay, he has to find a fruit now. He literally has to. Okay, he's wandering. Oh wait, maybe I need to set the target. Well, wander. Oh, wander is just a velocity thing. Else target is equal to null. Or target equals null, because target initially equals null. Because move is trying to move to a target. Right? If the target is null. I almost would have set this to wander, but it's fine. Wander's doing this thing. He's in the tree. Wait, isn't he supposed to be above the tree? Oh, he just ate. Nice. Although we are going to immediately call wander after this. Target null and wander. Actually, wander is going to set target to null. So that's what we'll do. Okay. So now he should just start immediately wandering again. Yeah. I also want to set a thing to where I'm going to do a thing here. Put it down here. Oh, well. Never mind. Okay. So they have to intentionally eat a fruit. Also, oh, that's right. I accidentally flipped all these. The order is going to be cells on top of trees, but then fruits on top of cells. There we go. Okay, and I want to give them a little bit more life. So we're going to go over here. Max hunger is going to be 20. So they're going to live for 20 seconds. Did I say that right? Value in seconds? No, okay. Value in seconds. Okay, let's see. He's still dying. You're right there, man. You can do it. He can't do it. Okay, so now that we have all this, we don't need to do any prints anymore. We're going to go ahead and bring the trees back to a small amount. We're going to make 100 cells. And we're going to see what 100 cells do. We're just going to watch them. We're going to watch them eat. With their horrible reaction times. These guys, luck of the draw. Bad luck of the draw for these guys. Real good luck of the draw for these guys. They're all going to die off. So if they eat within, we're gonna create a thing here. So we're just gonna start this. We're gonna go crazy. We're creating the mutations now. So we're gonna do private final int mutate threshold. Okay, threshold does have the 1H. Mutate threshold equals 4. So if they eat another thing within 4 seconds, well, actually, we're going to call it split threshold. So here's what we're going to do. We're going to create another if statement. If hunger is more than max hunger minus, what did I just call it? Split threshold. Then we're going to do this thing, and then we're going to set hunger to max hunger again. And we are going to... So if they eat within 4 seconds of just having eaten, they will split. We will do main.cellSpawner.add new cell. Oh, and now the cell is going to have a new constructor. Public cell. And it's going to take a cell super. We're going to do cell dot get position, cell dot get size, cell, well, and then the shape is going to be the shape. Isn't the shape always going to be the same? I don't know why we're making certain shaped cells. E shape dot square. Cells are always going to be square. Cell dot get size. I guess we'll call a this. Yeah. We'll call super. We'll do it the way I've been doing it. Cell.getX. Well, cell.x. Cell.y. Cell.w. Cell.h. E-shape square. Color.black. So now we're going to go down here, and we're going to construct it with this. So now he's going to eat. Oh, look at that. He made a new cell. Oh, but the cell, oh, okay. The cell does, oh, nice. Nice. Okay, so now they're reproducing too. Look at that. We're creating a whole little colony down here. Oh, they're going to reproduce a bunch because of all the fruits growing. Yeah, and I like 4 as the threshold. Okay, but when... Okay, here's where we are going to create some new global variables. Public static final int mutate chance equals 1. There's a let's make it 5. There's a 5% chance. Value within 0 and 100 as a percentile. Okay, so the mutation chance is 5%. Public static final. Wow. We're going to create a private final int starting mutation tries equals 4. So we're going to attempt to mutate stuff 4 times. Private final int starting mutations equals 1. So we're going to have 1 mutation automatically, and then we're going to try 4 more times. And then so this one is interesting. We're gonna call it a constructor. Public void mutate. Actually, public cell mutate, and at the end it'll return this. We're gonna do int tries. Then we're also going to create public cell force mutate. Int mutations. Or int count. Okay. So now, at the end of this, we're going to do dot mutate, dot force mutate first. Starting mutations, and then dot mutate mutation try, starting mutation tries. Here we go. We're going to split it like that so we can look at it. All right. This looks pretty good. We're going to call it mutation chance. And in all of these, we should call it mutate, right? Actually, we're going to do it down here. When you create a new one, dot mutate. And we're going to do main dot mutation chance. Yeah. We're going to do mutate, which is just going to be like automatically 1 try. Perfect. So now that we have our mutations, we're going to do the thing here. Mutation add organelle mutation based on chance. Add mutation based on chance. Add mutation based on chance with tries. Add mutation. Okay. So, here comes the meat and potatoes. New package in main object cell dot organelle. We're going to call these organelles. And we will create a new class. And it will be abstract organelle. It's going to be our new abstract class. Okay. We have got us a lot of work ahead of us. But it's going to be fun. Okay. Yeah, we have a lot to create here. A lot to create. First thing, it implements I-has shape because I want to see these, you know? I know to live, you must give your life away. I've been housing all this doubt and insecurities, and I've been locked inside that house. What if I do this? You know what? Screw this. We're gonna create a global. This. Okay, so now this is the global. This is the global constructor now. Because we're going to call the super, and then we're going to do this dot set size. Oh no, this dot w. So w and let's look at this. I shape? No, a game object. It is protected, but it is final. No, it is not final. It can be changed. This dot w. So we're going to create to do change size based on organelle count, because I want these to grow based on their organelle count. And I almost want them to move slower if they have more, but we're not going to worry about that right now. We'll add that later if we want to. I'm also going to add colons to these because yay. Now we have a lot. We have a lot of work to do. I think the first thing we're going to want to do. Oof. Okay. First thing we're going to do. Actually, not first thing. So right out the gate, we're going to create 3 kinds. This is mutable properties, and then we're going to go. We're going to have a speed, a strength, a speed, a sight, and a reaction time, right? We're going to do organelle variables, private int speed. We're going to call this total speeds equals 0. Total sights equals 0, and total reactions. And then we're going to create 3 organelles here. That'll be speed, sight, and reaction. To do organelle list or lists. Well, we'll do that. Organelle. Okay. We have a lot of work to do. And I mean a lot of work to do. I'm going to go to the bathroom first, though. All right, I have returned. I don't remember if this thing was copyrighted or not. Okay, first thing we're going to do is create protected int x, protected int y, but these are going to be the local and, well, the local x and y. We're going to go over to a game object. We're going to copy all of this and paste it here. And instead of returning these, well, we're going to create a cell. Well, not cells. We're going to create a global width and height of 2. Return e shape dot square and return this dot color, because we are going to create a protected color. Excuse me. So that does that. It's going to have an X and Y. This is where I got to think a little bit. I'm going to do cell. So it is going to have a variable that is the cell it belongs to. Final cell. But we are going to create a organelle. We're going to create a public organelle. Pergonelle, wow. Cell, this dot cell equals cell. So it's going to be, it is final. We're also going to create a, we're going to have color set. Well, we're going to create a protected abstract set color. Wait, why am I giving it that? Color. I guess it has to be public, doesn't it? Public abstract void set color. Can I do protected? Cool. Okay. Protected final cell. I'm just working through all this right now in my head a little bit. So X and Y and then cell. So this is going to be this dot, wow, cell dot X plus get X plus, and then get Y plus Y. So the X and Y are going to be that, and then we're also going to do a private or a protected void constrain, since this will move as well. Constrain is going to make sure that, well, let's go back to cell and find its constrain. Wait, I can look on this side. Oh, nice. Is it an game object? Constrain, there it is. Nice. This isn't technically a game object, it's an addition. Oh, but it's the window get limit. All right, I'm just gonna do it myself then. We're gonna start from the beginning. If this dot x plus 2 is less than, well, if this dot x is less than cell dot x, and then if, and then we're going to do with y, has been hoto. And the same thing, but with a more than, this dot x plus 2 is cell dot x plus cell dot get w. There's no question a big pose, a son only case closed. To never get that hell is forever. A man only lives once. I'll see you in 1 month. Gotta say, I can't wait to come down and exterminate you. I hate him, but I love it when he sings. It's always top notch. Okay, so now that we have this, we're gonna set this dot x equals cell dot, oh well, cell dot get x. Then this dot y equals cell dot get y. And then this dot x equals cell dot get x plus cell dot get w. And then same here, this dot y equals cell dot get y plus cell dot get h. Cool. And for those who are confused, h is height, w is width. Hopefully this will work. We're gonna test it, of course, because that's what we do here at the something incorporated. I don't know what I'm saying. We are gonna go ahead up here. Well, we don't have that yet. So now that we have all these steps, angel just like us. I'm gonna create all this. Then I'm gonna create a protected int speed we're gonna create protected int speed, move speed, and a protected int move amount. So the move speed and move amount, basically I want the organelles to move inside the cell so it looks super alive and whatnot. I had it before in my old one, and it looks really cool. I like it. But now, protected abstract void set speeds. We'll set speed. We're gonna do int speed int amount. And I guess we'll create a protected void move. And it's going to do I guess we'll use randomness, because that's what we do here at Affirix Incorporated. Or here at Western Sunset Productions. Why am I blanking on how to move? Okay, we're gonna do this dot. We're gonna create int vel x, int vel y. We're gonna do equals main dot random dot next int. And same thing here. So now we're gonna create a thing where we're gonna bind it. Oh right, first it's gonna be between -1 and 2. -1 and 2, so it's gonna be between -1 and 1 because it doesn't actually include 2 because of how random works, and it needs to work best for array lists and whatnot. We're not gonna worry about that. So now it's gonna choose a vector. We're gonna create a vector with that. Although, can't I just... Yeah. vel xy is going to be an xy instead. New xy. X and y. Well, xy dot random. -1 and 1. Oh, I guess we're doing that. There we go. And we're going to go over to xy and peek that real quick. X min, X max, Y min, Y max. That's how we're doing it. There we go. So then we're going to do this dot x plus equals val dot x times move amount. And then this dot y is going to equal the same thing, but with the move amount. But we only want to move based on the amount of tries. Oh, yeah, we're going to create. Okay. So with this, you're going to create a new thread. Well, the motion thread should be able to take care of it, actually. And it's tick bound to 120. So for every cell, it's going to do cell.move. And cell.move is going to call, well, do I really want to do that? Right, because cell.move, if I'm correct. Yeah, perfect. So the cell is going to take care of the movement. So move speed is going to be public instead, because we want the cell to be able to call move speed. Calculated value in frames. Well, we're not even gonna, that's fine. I'll remember that. Okay. Well, I guess we could also put it in. Yeah. We'll create a private int move tries equals 0. I'm going to put this all in an if statement, which we're going to write up here first. We'll copy all this down. So it's all internal. Internal is good. We like internalism. And then move tries ++. And then move tries, do all this. Speed. Move speed. So we're going to check if, and we're going to do this. Move speed. So it is going to be called all the time by the cell. Which, I'm trying to think. Oh yeah, and then constrain. I'm gonna go to this dot because we like this dots sometimes. Here's where things get interesting. Yeah. We have our move, we have our constrain, we have the color and speeds. What else does an organelle need? I don't believe it does. So when we create it with a cell. We're going to do this dot x equals cell dot get center dot x And this dot y is going to equal the same thing. We do not want to insert. Whoops, not t. So we're going to put it in the center first and foremost. Well, -1, I guess. Because of the width and height. And then, here's where things get fascinating. We're going to want to set, the color is going to be its own thing. Yeah, these are going to be set separately. So you just create the cell. Okay, so now we should be able to create our other organelles. We're going to go ahead and just start with speed. I remember I called these plasts. Speed plast. Which is going to extends organelle. We're going to add the constructor. And then we're going to add unimplemented methods here. I might be like Angel, but I might. All right. The color is going to be different. It's going to be this dot color equals new color. What is the color going to be for speed? We're going to say it is 170 red. We're going to make it, well, speed's going to be blue, mostly blue. But we're going to do like a light blue, so we're going to do 70, 70, and then 200. That should be pretty good. And then this dot move. Oh, I guess color and speed didn't actually have to be, interesting. Very interesting, actually. Maybe we don't need to do this. Yeah, we're gonna do color, color, and then int move speed, and then int move amount, and do this dot color equals color, this dot move speed equals move speed, and then this dot move amount equals move amount. So back at the speed plast, we're gonna move this, boom, and add all this in. We're also gonna create a public speed plast. This is going to be private. We're going to do cell. This is going to be cell color, or well, new color, which was 70, 70, 200. And then move speed is going to be, so the move speed is how many, within how many frames it updates, right? I want this to be jiggly. It's going to update every 2 frames. Hell, every 4 frames, actually. Move amount is just going to be 1. And there's that. We've created our speed plast. It's not doing anything yet. But what we'll go ahead and do is create, whoops, a hash list. Well, I guess we can just create a list. Private list speed plast equal speed plasts equals new list. And I guess I want to import, oh, change to JList. We're going to do a hash list then, because we just want to get the size. Hash map, that's what it is. Import speed blast. Hash list. Hash set. That's what it is. So now we have that. Total speeds is just going to be the size of this, right? So do we actually need this? I don't think we do. Cool. Yeah, okay, this is weird. I guess it's custom, so we're not going to worry about it. We're also going to go through, we're going to create constructors, getters, and setters, backend variables, and whatnot. Well, we're going to create this down here and create a public array list, organelle, all organelles, return a new array list, organelle, well, I guess not return, array list, organelle, list equals new array list organelle. We're importing that, we're importing that. We're just going to import all the organelle stuff because all of it's going to be necessary. Then we're going to do list.addAll, speed blasts, then return list. Then we're going to do to do add all lists. We're going to do this. And selected projects. There we go. Excuse me. Cool. So now we're going to go back over to the window because the window's going to have to paint all the organelles. Okay. This is where things get scary because I hope they don't go slow. We're going to do this again. I has shape. O. I dot get. Well, we're going to go cell. We're getting a cast to cell for I dot all. Well, cell I. I have to do it like that, right? Dot. What do I just call this? Get all plasts. All organelles. There we go. So we're getting all organelles. This is scary. Oh. Oh, G2D dot set color. We can even split this to make it better. O dot get color. And then draw object. So this one's going to be interesting. G2D O dot get rect. O dot get shape. Then again, we could just set these to be the shape that we know we want. We're not going to worry about that for now. O dot get shape. It would probably free up memory, but I'm not too worried about that. I have like 64 gigabytes of memory. Okay, let's see if this works. Right, I need to add one. To this one. Speed plast dot add. New speed plast. This. And then let me make sure down here, well, mutate, I guess, is what I'm doing. Let's just try this. Oh? You see all these? Interesting. Very, very interesting. Let's go back to organelle and look at this. I guess we should really just return X and Y, huh? Because we're binding it elsewhere. Let's try that. Aha, you see them? They're just not moving. So now in the cell move, where are you? And then after this, we're going to do this dot all organelles for organelle O. This dot all organelles O dot move. Whoops. Move is public, right? No, it is protected. Public. O dot move. Oh, you can see them. Okay, they're very dark, so we're gonna go to speed plast. 255. I'm gonna do 140. 140. They're just lagging behind is the only issue. Very much lagging behind. O dot move. Let's look at this. Move tries is 0. Oh, yeah. Move speed. We don't actually have to use the main tick rate. Move tries minus equals 1. Let's try that. Oh. Equals 0 again. Whoops. Okay. Move tries get set to 0. But then we're incrementing it. So I guess set it to -1. So now we want to make sure it's being set inside the cell a little better. Whoa! This dot x. So let's do cell.getx +1, y +1. Then do cell.getw -1, -1. You see, it's still going wherever it wants. Oh, this puppy wants outside. Let me let this puppy out of the door real quick. Actually, I gotta deal with the puppy first, so I'll be right back. All right. Did you guys like that last song? It's January by Afurix. Self-promotion. Okay. I did realize. Never mind. I already added it. I realized something down there, and I'm like, oh, well, I guess... Huh. I'll do little minuses here. There we go. All right, let's look at this again. They're just going wherever they want. Okay. They move by the move amount. Then they're constrained, which should work. Let's say that in the speed blast, the move speed is 10. So it's got to try 10 times first. Okay, so that constrains better, but yeah, as you can see, it's not going so well. Ooh. I'm going to let this song play. Why not? Okay. If this dot x is less than... Okay. Vel x times the move amount, which should just be 1, and it is. If move tries is equal to or more than move speed, which is 10, and move is being called by the cell after movement, we'll go ahead and scoop move tries up here. But then the problem here is something. I don't know what the problem is, I'm going to be honest. It's being constrained. Are the constraints bad? If x is less than... There's x. Initially set to the center. I guess whenever the cell moves, it should also move the organelle. Oh, but I liked the drag that it gave it beforehand. You know what? No. You know what? Yeah, I am. I'm going over here and I'm peeking at the organelle. I'm peeking at the old organelle real quick. Don't know what that's about. Yeah, vibration frequency and strength is what I called it. Update. Let's take a peek here. Well. Back to the organelle. It creates a velocity. Since this at x is plus equals val x times move amount, which is just 1. If I were to set move amount to a lot, it would go crazy. We're not going to worry about that yet. But then it calls this dot constrain. Let me open that up again. Where's the constraints? Nowhere? See, this is still odd. So the cell, it should be referencing back to the cell in which it is home to. Protected final cell. And the cells... Let's create one for now and follow one along, shall we? Where are you at? All right. It's just trailing off. And then it teleports back. It does okay with the upper values, but just not the lower values. So we don't need to touch these. These look okay. If this dot x plus 2 is more than the cells x plus the cells w minus 1. I'll even put these in parentheses just to make sure. Even though I don't think the order matters in that case. You see? What I gotta do with y as well. That's okay. That's not okay, but it keeps jumping back. It's almost like you want to constrain it first. Okay, we're going to try that. This got constrained. Instead of this, we're going to do an XY. And we're going to return an XY. Return XY, return XY, return XY, return XY. And we're going to replace all the thises with XY. At the end, we will return XY, just in case. So now, we're going to create XY delta equals new XY with this dot X and this dot Y. And then delta dot X, well, we'll do delta dot add val dot multiply, move amount, and then we will do delta dot constrain. Delta equals constrain delta. Delta equals constrain delta. And then this dot x equals delta dot x. And then this dot y equals delta dot y. So we're doing the math first and then applying it. We'll see how well that works. Oh, it's working a lot better for the upper move. Oh, mostly better for the upper movement. Let's try this again, see if it decides to wander elsewhere. Because it was very set on that direction before. See, it's still not doing well with that. Oh, I'm getting videos. I'll check this out in a second. We don't have to return XY yet. We're going to do all of it and then return XY. Minus 2. Actually, minus 3 if you think about it. We're not going to worry about it. We're just going to do minus 2. We're going to increment.
Okay, we can follow it with more cells, so I'm going to go ahead and add the 100 cells back so you can watch all of them go. Okay, we're going to do -3. Wait. I know what I'm doing. I got to make sure it's minus the width as well. That's what I was doing wrong. So now for something moving up and right, it constrains beautifully. They're all going to fade into non-existence. We're going to go ahead and brighten the speed plast a little more. It's a great song, guys, if you like it. It's Boss Fight by Afurix. And it's created with the same organelles. Nice. Nice. Cool. I like this a lot. This is looking much better. We're going to bring it back down to 150. I do think the organelles are a little hard to see. So we're going to make them 3. We're going to make them an odd number because we're quirky like that. Nice. We've officially fixed them. So now we can set the speed class back to moving on 4s to watch it go crazy. Yeah, look at that jiggle around. This is looking a lot like the old one now, and I like it. And I like how they drag. Oh, it's all coming back. We're going to go ahead and set the default width and height of a cell. I believe it's here, right? 10, 10. We're going to do 15, 15. Oh, they're huge. I think 10, 10 is fine. I think if they're small, we're okay. We're going to leave the organelles at 3s for now. We're going to make these jiggle around even more. See if we like where it's at. I do. We're going to go back to the cell and we're going to go ahead and fix this up. So instead of adding the speed plus like that, we are going to... Oh, that's right. I remember I had a static list of organelles. All organelle subclasses go here. We're going to create a public static void. Wait, not public static void. Public static final organelle array equals speed plast. How did I do this before? Let's find out. Always good to see before. Oh, all. That's what I did. We're not going to worry about that yet. We're going to go back here a little bit, and we're going to try and do it on our own.
So add mutation based on chance, add mutation based on chance of tries, and just add mutation. Oh, yeah, that song. Oh. There, I'm turning up the volume that way as well. Because I love this song. Okay. Force mutation. We're going to do for int I equals 0, I is less than count, I plus plus. So we're going to do we could do a list of lists for the organelles, but I don't think I want to do that. For now, well, first we have to make the other plasts. So we're going to copy paste speed plast, do site plast. We're going to do that and do reaction plast. Site plast and reaction plast are going to be different. Site plast is going to be mostly yellow. It's going to be all yellow. It's going to be bright yellow. 220, 220. And it is not going to move often. It is going to move probably every half a second. Twice, so it's going to move twice per second, but it's going to move by like 5. And then reaction plast. It's going to be pink, so we're going to do like, we're going to do 255 for red. And then 150, 150 for the other two. And then in the cell, we're going to create 3 lists. Site plast. And reaction plast. Reaction plasts. Excuse me. And site plasts. Excuse me. I don't know where speed plast is being used. Ah, yes. Site plasts. Reaction plasts. Beautiful. So now, in force mutate, you're basically we'll create a separate private organelle, random organelle. This must contain all subclasses of organelle. So we're going to add that there. Return. For now, we're going to return null. So we're going to want to create a thing. It's almost like we're going to want an enumerator of organelle types, just so we can randomly go between them. We're going to do int types equals 3. Count of organelle subclasses. Then we're going to do switch on types. Case 1. Break. Case. Oh yeah, I can turn this back down. What's wrong with me? There we go. Case 2. Break. Case 3. Break. And then default is going to break. Default is going to return null.
That's right. I don't actually have to do that. I can return instead of breaking. System.error.print line. We're going to do a thing here that lets us know something bad happened. Error. Cell attempted to create an organelle. With an out of bounds type. Plus types. Well, plus type. Int type equals main dot random dot next int between 1 and types plus 1 type. All right. And then we're just going to add a case here for each one. Add case for new organelle subclasses. Subclasses. Okay. So now, for this, we're going to return new speed plast. This. A new site plast. This. And a new reaction plast. This. So now, if we go to random organelle, where did we want that? In force mutate. But now we can get random organelles. Organelle. Let's do organelle new plast equals random organelle. Then if it's not null, if new plast is not equal to null, then we will do I almost want to create a global list of all the organelles and then just add to a count. So let's do this. Public hash set organelles equals new hash set. Okay. So organelles dot add new plast. Perfect. So that should work there. We're going to go down here. And we're going to delete this. We're going to go into window and just do organelles. And make sure it's public. It is public. All right. There we go. Actually, I'm going to keep this because we want to return an array list. New array list organelles. There we go. We're going to go ahead and remove these because they're not used. We have our organelles. Then we're also going to have private int speed plasts equals 0. And do this for site plasts, and reaction plasts. And then we're going to do Ah, I know what to do. In organelle, we're going to create a protected abstract, modify cell. Public abstract void modify cell. And now in all these, we're also going to do this dot modify cell. So now everything is going to be modified. We are going to add on methods. Add unimplemented methods. Add unimplemented methods. And then add unimplemented methods. We'll do that. Cell dot well. Let's go over to here, and instead of making these private, they're going to be public. Cell dot speed plasts plus equals 1. We're going to do that with site plasts. We're going to do that with reaction plasts. So that should bring these up. So we will go ahead and do 1. And on update, let's do it on React just cause. System.out.println speed plasts plus side plasts plus reaction plasts. Oh. Plus reaction plasts. Perfect. Why is it? Maybe constraining it would be a good idea to do when the cell moves as well. So we're going to do that, but we know this works. So we're going to do this, force mutation, and then we're going to do it with tries. Well, we're just going to copy this. Tries. If main dot random dot next int between 0 and 101 is less than or equal to main dot mutation chance. Then we're going to do this. Add mutation based on chance is just going to be this. And then I actually will just do this dot mutate. So mutate based on chance, mutate based on tries. We're going to make 100 cells. Some of these have multiple. Perfect. Oh yeah, and the reaction plast is going to have 2 moves, but it's only going to happen 4 times a second. Oh, and I could... Oof. We're going to do main.tick rate divided by 4. Speed plast is always going to happen 2 frames per second. It's going to go crazy no matter what. And then recite plast is going to be main.tick rate divided by 2. There we go. Okay. So now that's done, we're going to go back into cell. O.move. For all the organelles, we're also going to do O.constrain. We're going to do a private or protected constrain. We're also going to do a public void constrain. O.constrain. So we're going to do a second pass of constraining. We're going to do this, but we're going to replace xy's with this. There we go. And then we're going to return. Well, we're not going to return. We're just going to do them all with the same exact thing. Okay. So they're all doing their thing. But whenever we call mutate, we're going to do a backend function, random organelle, all organelles, and then we're going to do private void affect variables. Affect mutables, actually, is what we're going to call affect mutables. So this dot speed equals, we're going to want a default. So let's set defaults. Private float max speed. Private final float max speed equals 10. Private final float max reaction time equals 1. Floast? Why, I did it again. I did floast again. Private final int max site equals 10. Then we're going to set this to max that, max reaction time, and set this to max site. And then we're going to go down here to affect mutables equals this dot max speed plus this dot speed plasts. So we're going to increase the speed by however many speed plasts there are. Let's do it times an amount for now. We might just make it 1, but for now we're going to multiply it by 5. This dot site is going to equal this dot max site plus this dot site plasts times 2. And then reaction, this dot reaction time equals this dot max reaction time plus, so how does reaction time work? I believe we have a try react. Reaction tries. Main divided by reaction time. Let me turn this so it's good. The volume's okay. What are we going to increase the reaction time by? 1? It's not a huge change, but it certainly gives them a leg up. Let's take the reaction time and let's add let's go for, well, this dot reaction, let's take that. This dot reaction time equals the max reaction time, and then 4 int I equals 0. I is less than reaction plasts I++. Let's add this so it's just a little easier to read. And then for this, we're going to do this dot reaction plasts multiplied equals 2. So we're going to copy this. Excuse me. Before I go back, I'm going to go and check these videos. All right. So, affect mutables. We have it. It's going to multiply the reaction class by 2 every time. We're going to cap it at a certain amount. I think it auto caps, honestly. So, with this, we're going to go ahead over to mutations. Oh, actually, we're going to take this real quick. We're going to take the to-do, and we're going to put that under affect mutables. Back to affect mutables. And now we're going to copy affect mutables again and go back up to the mutate ones. Affect mutables, return this. Affect mutables, and return this. So that should do it. Well, I guess we don't have to call affect mutables if mutate is calling affect mutables. So there we go. This should do it. So there should be some. These guys should move faster than these guys. Oh, and he does. You can see it. He moves quite a bit faster. So now, every time they reproduce, after they eat, we're going to go to update. No, try react. We're going to go to react here. We're probably going to reorganize this whole thing as well. But under try react, under react, oops, dot mutate. Oh, it already mutates by the 10% chance. So let's look at this site guy specifically, because he's about to go over to these fruits. He's going to eat one. He should have enough sight to go over to this one. Ah, hello. One moment.
Alright, I return again. Lots of leaving this stream. Okay, so let's take a peek at these guys again. This guy has 3 mutations, which is insane. He's gonna eat that, but he still doesn't have enough. Let's follow this man, because he's about to hopefully run. Oh no, don't do it, man. You got this. You can do it, you can do it. Yes. He has a reaction blast, so he shouldn't be the most inadequate. There we go. There's 2. Oh. Creating the new one had no mutations, which I find odd. I find very odd. It creates a new cell with this, so it should be a copy of this, and then it also mutates the cell. It should anyway. We could always just split this, do cell, new cell equals new cell. This new cell dot mutate, and then just add the new cell. Let's try that. Let's follow along this man here, because he's gonna come to this fruit in a second. Oh, or he's gonna pass right by it. His sight really is not good. These guys, okay, he just split and created new cells that have nothing on them, which is disappointing. So what made it work beforehand? That's what I find quite odd. When you create a new cell, it should have all of the mutations in place, right? It should. When you create a cell with cell, we're gonna add this real quick. This dot organelles dot clear, just in case. This dot organelles dot add all cell dot organelles dot all organelles. Let's try this. We'll follow these guys around, around this tree. Oh, well. Maybe not. We'll follow this guy. He'll run into that, he'll eat. He'll run into that, he'll eat. And, a new one. But not exact. Huh. Cell dot organelles. How about that then? Let's try that. These guys should be able to eat some organelles. That guy's going fast. Come on, you can eat. I can't believe you missed those. Their sight really is not good. Oh, but he made another set. Okay, so something is clearly not going right here. This is slightly disappointing. We're gonna give these guys a little more sight. And how much sight do they get when they affect mutables? They get 2, so we're gonna give them max sight is gonna be 16. Okay, this is getting a little sad because it was working so well before. I almost want to look back through the stream just to see. Maybe what we can do, we do a new cell. This new cell dot organelles dot add all this dot organelles. We'll try that. This guy's ripe to eat. Well, he was. Ah. And they're blank again. What is up with that? I do not appreciate it. I do not like this at all. For some reason, this just is not working. Why is it not working? Does it have something to do with what a hash set is? Possible. It could be that the hash set just has organelles instead of... Okay. We're going to add a new thing then in the mutations and constructors. We're going to call them mutation methods. We're going to make a new thing called protected void inherit array list organelle. I think it's because they're not specific anymore. Organelles. We're going to do for. We're going to do this dot organelles dot clear. Then for int I equals 4, I guess, organelle O organelles. This dot organelles dot add. Oh. Let's try this. This could be good. Never mind, I never called inherit. Back down to where the new cell is created. New cell. Well, first new cell dot inherit. Dot inherit. This dot organelles. Oh, new array list. Organelle. Organelles. Let's do that. One of these guys should be splitting. Oh, okay. Well. This is... Oh my goodness. No, they all extends organelle. I thought I'd made them not extends organelle. That would have been insane of me. But that also wouldn't make sense either. So I am stuck for some reason. Let's go to inherit. System.out.println organelles.toString. Okay, it's a site blast.
Pull the T's gear.
Let's try it with 1. Let's try it with 10. So I can track him a little better. Sight blasts. Come on, guys, eat something. I want to see if you're actually blank. They supposedly have sight blasts. Organelles add. Oh, new organelle. Ooh, ooh, yeah. Let's do if o dot class. Well, let's do site. Let's do speed plast dot class dot is instance o. If o is an instance of speed plast, add all if through all organelle subclasses, else. Let's do this. The master. I love this. Playing it especially. Else if. Else if. Let's do reaction and sight. So this is a bit of a brute force way to do it, which I don't like. I liked it when it worked before. I like it when things work. But the problem with that is doing new organelles. And we're going to have to do this anyway, so then we'll do this dot organelles dot add new. I almost do want to make an enumerator now. New speed plast. This. This will add a new sight plast, and this will add a new reaction plast. So there, inheritance is done. So this should work. I don't think I'm printing anymore. There we go. We should come out with some new mutations. There we go. New mutations. These guys should start mutating a bunch. Having better sight and better reaction time. But they should mutate other stuff too. So one of these should get speed at some point. They're going to start to eat each other out. Wait, pause. Ooh, I should add a new lifetime plast. What should I call it? Constitution plast? Is that too much? Should I do resilience? Yeah, Constitution plast. Constitution plast. We're going to go back to cell. Okay, we're adding this right now. I didn't have this one before. Public int constitution plasts equals 0. Constitution plast. Then it's going to add 2 seconds on to the max life. Constitution plasts. Constitution. Love this song. Hopefully it's not copyrighted. Which some of the songs are copyrighted, but just in Russia, so I'm sorry, Russia. About that. So we're gonna go ahead and add one. Else if Constitution plast
is instance. Sunny's pennies in a vending machine of love, and grab that busy lit on me, say you've been dreaming of. Constitution Blast. Now we're gonna go down to random organelle and do case 4. Return a new Constitution Blast. This. And we're gonna do 4. Nice. And then affect mutables. And then now this dot Constitution. Well, sorry, it's this dot. Max Hunger. Private int max hunger. Private final int max hunger equals 20. We're gonna set this to max hunger. We're gonna add that there. We're gonna add this. And add it to here. Make it protected. Then we're gonna add this. Lifetime variables. So this dot max hunger equals this dot max hunger plus Constitution Blasts times 2. Then that should do it. So Constitution Blasts should be, what color should they be? We're gonna make them orange. Like a bright orange, but not super bright. So let's do 222. And they're gonna move main.tick rate once per second. And it's gonna move once. So they're gonna be slow. I don't see any here. We're gonna go back to 100 plasts cells. Any orange boys over here? Yeah, I don't think so. So something's up with being able to add Constitution Blasts. Random organelle. A new Constitution Blast. All organelles is there. Random organelles here. Constitution Blast, I made it orange. Oh. That's no, those are fruits that are appearing. Honestly, I want the Constitution Blasts to be thick boys as well. Protected int size equals 2. Well, 3 actually. Size. And now we're gonna do I also want speed blasts.
this dot size equals 2. Constitution plus does this dot size equals 4. So I want speed plus to be smaller as well. But now we're going to go over here and do minus size minus 1. Minus size minus 1 plus size plus size. That should do it. I hope. Yes, now the speed plasts are super small. But I still don't see any constitution plasts, even though we just added them. And it should have been added. It's all there. Here in cell, random organelle, types +1, types is 4. Switch on type, and create a new constitution plast, which exists and extends organelle. If through all the organelles, let's go ahead to constitution plast, and whenever it's constructed, we are going to system.out.println conplast. Well, supposedly they're being created. Oh, they are. They're just really yellow because I think I forgot how colors work. 255 in the orange and 150, or 255 in the red and 150 in the yellow. Well, they don't look very orange. Why is orange so difficult? Okay, so they are working. Constitution plasts are being made. It was just the color was so similar to all the others. Oh, maybe yellow is the main color in orange. Well, now they're green. Odd. RGB. Guys, I'm an idiot. I'm an idiot. RGB color picker. Well, there we go. There's orange. I want that kind of orange. So 251, 255, 200. Should be orange. Well, it's certainly orange-ish. It just also looks a lot like the reaction plasts. Let's go through all of these and use color pickers because I forgot that it's RGB. Oh, give me 1 second here. All right, I'll be right back.
right, back at it again. All right, where were we? We were with the colors. I don't hate the speed blast, but we're gonna play with some colors here. So I want a dark orange that isn't really red. So let's do 255 100 for Constitution. For the reaction blast, I want it to be a nice 200 200 here. Whoops. For the sight blast, I want it to be a bright yellow. Even a yellowish green wouldn't be bad. So let's try 240, 240, 15. And then for the speed blast, 15, 200, 255. Yeah. Let's try 100. I like that. That's a little better. I like that the Constitution plaster just dragged along. Okay. So we have our mutations. We have a lot, actually. So let's create 500. And let's watch them go. Those guys, those two little speed cells just fought over that one food. So most of them are going to die because they didn't have food. In fact, let's make some more trees as well. Let's make 10 trees. Here we go. Now let's just watch it. Let's watch the simulation unfold. Okay. Oh, something happened here. Cannot read X because this dot target is null. What? Okay, yeah, you're fine. To target. If target is not null. Hello. Hello. Target can't be null. This dot to target. This, yeah, target. If target is not null and the position is not equal to the target. If target is not null. There it is, right there. Why was target null then? Do we want like a secondary check? Is that what we're asking for now? I'm not checking it twice. That doesn't make sense. Hopefully that was just a fluke, but I don't like that at all. We could do a null pointer exception try catch. Wow, this is a ruthless one. Look at all those deaths. We got Constitution in sight. I almost want to add a bias to create more of the same one, but I don't think I like that. These speedy boys are certainly doing a lot. Oh. All right, let's just let this thing unfold again, and if we stop at another null pointer exception, we will do a try catch. Okay. I don't see a lot of new trees coming up, which is scary. But I guess that's just the way the universe. It's cruel and unforgiving. All these Constitution guys are surviving a lot. And all the speed ones over here. Looks like speed and Constitution are the main
winners. Got some guys over here that are reaction speed, it looks like. Then over here, they're kind of dying out because they don't have a ton of food. But so far, they look speed and reaction. And then, of course, I want to add behavioral organelles. So, like these big ones that determine whether or not the cell does a certain thing or acts a certain way, including eating other cells or sharing with other cells somehow. Like seeing if someone near it with the same, like, I don't know, maybe add family behavioral things. We'll see what happens. So far, I don't like the fact that there are no new trees. So I think I might add a little more to the chance that a tree might grow. It's interesting when they just start shaking to eat. I almost want to do a constant check too. If they are in food, they eat. Yeah, I think that's what I'll do. Let's add a constant checker to see if one of them is in food. I almost want to go to the restroom and see how this turns out. I'm going to let the stream show it. I'm going to hit the restroom. All right. Oh, good song. I'm back. I see the trees have not died off yet, but we also don't have any new trees. Is it not spawning new trees? Is there a problem with that? I might check, or we just are really unlucky. So far, we have a lot of sight going on where the speed used to be. Excuse me. A lot of sight where the speed used to be. This is still speed and reaction, it looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. I almost want to make it useful to wander out. But only when you know you can. I don't know. There's definitely some stuff here that... Oh. The way they all spread out when there's no food. Like that. Like, okay, look around. Find food. I don't hate that. Never mind. I think I might have them wander more in a certain direction. So, like, make them change their direction less often. And I want them to grow based on how many mutations they have as well. So far, we got a lot of sight going on here. Sight is very useful. There's just lone tree over here. Oh, this is interesting. Oh yeah, and I also want to make it to where they have to eat more based on how many organelles they have. Based on their size, pretty much. The bigger you are, the more you gotta eat. I'm liking this. This is cool. These are very wild and random, whereas these are like, they're all grouping up in the same area. We're going to go and stop the simulation here. And we're going to make sure. We're going to go over here and say that. Wait, we're in cell. In main. Is it in fruit? Fruit size and lifetime, no. Let's go to fruit. Grow chance, there we go. Grow chance per 100. So there's a 10%, there's now a 1% chance to grow a new one. A new tree. So we should see new trees popping up everywhere. Okay. I'm not seeing any new trees. I saw a lot of deaths just happen. I want to keep a log, like a text log, some sort of main variables, and then at the very end, when it kills itself, when I exit. Okay, that's it. A 1-in-1 chance to grow a new tree. They can't grow new trees because the fruits are being eaten. That's why. No wonder. I almost want to make it to where random trees will pop up about the place as well. Oh! Oh, bound must be greater than origin. Okay, but that it did try. So the fruits will have a chance to grow a tree. If they die. We can also make green thumb cells. I think in the tree thread. And then a 20th of the tick rate. We're going to create a private int new tree delay equals private final int equals, let's say every, so if we're doing a 20th of the tick rate, how are we going to calculate? Well, let's do it in seconds. Every 60 seconds, every minute, it's going to grow a new tree somewhere. So, private int new tree delta new tree tries equals 0. So, I'm going to do new tree tries plus plus. So every X amount of time. Okay, so let's think about this. 120. So it comes out to 6. Well, 120 divided by 20. So the rate is 6. Let's go to the tree. We're not going to worry about that. So, wait. I am just not... This isn't calculating for me for some reason. I am dead. Let's go to tick bound thread. Whatever the tick rate is, so tick rate, something divided by tick rate. So this value divided by tick rate is going to be 120 times per second. So this is only going to be 6 times per second. So this is going to call 6 times per second. So every second, so whatever this is times 6, new tree delay, yeah. If new tree tries is more than or equal to new tree delay value in seconds, new tree delay times 6, then we will do well, we'll do this. Main dot tree spawner add object new tree somewhere in the window. A message from Graham. We respond to. Okay, we're gonna create a new tree every minute supposedly. So let's take a peek at this. Let's see if this. Actually, let's try it every 4 seconds first. 1, 2, 3, 4. Uh oh, wait. And then new tree tries equals 0. I do not see any new tree. There's a new tree. 3, 4. Okay. So that does work every 4 seconds ish. So every 60 seconds, and we're going to set this to -1, just to make sure it's perfect. All right. Let's let this run. All right. So we should see a new tree here in about a minute. But also new old fruits should grow trees more often as well. Like I'm thinking this group might make a new tree. Nothing so far. We're probably going to generate whole new forests pretty easily with this new random tree spawning thing. Yep, there's a new tree from random after about a minute. I think that's about a minute, right? I don't want it to be too often. I do want it to be accurate to my variable that I set. Oh! And this is gonna grow new forest too if these fruits make a new tree. Waiting for another random new tree, as well as new trees from. There's another random new tree. I'm trying to see if there's new trees from the fruits as well. This guy could start a new colony. Nope. Okay, so now wandering is worth it. They might start new colonies. So I'm not seeing any new trees from the fruits. So I might up that chance by like, I might make it a 1 in 500 chance. Per pentasecond? I don't know. And then of course I want to make it to where the size changes. Cell size changes based on how many organelles it has. See, these aren't making new forests, man. They should be. We're going to go and change that real quick. Back to the fruit. And we're going to make it a 1 in 400 chance. That could totally be way too often. But we're going to try. All right. Let's see here. See, I'm liking this way better now, even more than the original. And I'm almost to the point where this is the original. Oh, I set those things to max, but I meant to set them to default. All the things, like all the names for the variables that were the default variables before the modifications, I meant to call them default this, default that, instead of max. I'm going to go back and change that here in a bit, and then I'm also going to add a default size variable that will, well, be used for new sizes. I like the new Constitution Blast, though. That's new, you know. That's something brand new. They get 2 seconds of life every single time they get a new Constitution Blast. And I do want to make a thing where if I click on one of them, it'll print something to the console. But I'll take care of that way later. So far, I'm liking this. I don't see any... I think a tree did grow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, but it grew near a colony. Which is officially what I'm calling these. Ah! Alright. I really want this to grow New Forest. But I don't think the tree growing is working. All these Constitution ones here. Getting some sight and speed fighting over here. Sight and speed combined over here are dominating a little bit. And looks like speed came out this way. Again, I'm wondering about the fruits. Maybe a 1% chance. Let's try that. A 1 in 100 chance. Also, new tree. They're stuck at center minus tree size. Public static final. This dot get center. Dot subtract by tree size. Okay, let's give this a try. Maybe we'll see more forests. I hope this song isn't copyrighted. I just realized it might be. And while we're doing this, we're going to go back to cell. We're going to let this run. Yeah, and I'll go back to the cell real quick and down to the trying of updates. To do make the actual eating of the fruits happen outside of the reaction time. Okay. So let's see if this turns into a forest. This one over here. I hope so. Because I like that function. Oh! It is now. Is it going to be too often, though? It's not creating fruits, which I find scary. Okay, it is. It was just creating them here. Okay. A 1 in 100 chance. Ooh. It's going to create forests by the billion or something. Maybe the 1 in 400 chance wasn't so bad, but I really like the forests idea. Because it'll keep growing exponentially until cells get there, and then they can flourish. And I like that. We'll go ahead and set it real quick while that's going to 200. They've found the forests. We have a bunch of reaction ones over here. The reaction time seems to be kind of so we're going to go to affect mutables here. And we're going to do, oh, it multiplies by 2 every time, so it isn't actually that bad. All right. See, this isn't not. Oh, this isn't too bad. Yeah. Again, I gotta add the size difference thing to where they actually grow, so you can probably see the organelles better that way. Because it's kind of hard to tell how much you got going on, but let's look up. While that's running, I'm gonna look this up on the side. How resource expensive is Java's random? Efficiency of random method. Yeah, the way I'm doing it is actually the best way to do it. I'm going to put this back here and come back to this. Oh, the stream quality is just dying right now. Oh, but it came back when I switched that window over, huh? Well, the cell count is definitely flourishing. Like they are not hungry, but these trees are all going to die soon. Luckily, trees will always be growing because of our new tree method thing. I almost want to add a little bit to the what was I going to say? I want to add a little bit to the mutation chance. Make it maybe like a 12% chance or a 15% chance. Then again, look at these guys. I love the way the organelles drag. I almost want to make an option, like a Boolean value, to like follow motion. So like the site one and the constitution one will actually follow the motion a little more. But I like how the constitution one drags. So I think just the site one will be the one because I like it the way it looks around. It looks like an eyeball going, wow, looking around. Okay, so we got a lot of speed going on here, a lot of sight going on here and up here since these are connected. Looks like we got a solid mix of things between here, and I noticed Constitution isn't that big of one for this. It's like changing the fact that there's a bunch of trees. The cells don't need to be alive for as long anymore. Granted, this is all based on a natural selection, but like
you know, these guys should mutate something. Doesn't look like it. Ooh, hello, Cersei. It's funny, when I see the speed ones go around, they almost never grow 2 speeds. For some reason. Oh, but they just grew a sight, and there's one with 2 speeds. This guy, this is the big man right here. He's going to invade. Oh no, but he might die. He might die on the way there. He didn't have enough constitution. You can do it. You can do it. You can do it. You can do it. Oh no, he died. He's dead. He went somewhere up there to die. Who's gonna claim this new forest? Or this new tree, anyway. It's not much of a forest right now. Okay, it looks like they're gonna sparse out now that there's not as many trees. But there's gonna be like a tree that gets created here, possibly, and it's gonna create a whole forest, and something's oh no. All of these sight ones, they're gonna die once this tree dies out. You guys gotta start going. Migrate. Oh, then again, they're also here, too. Yeah, I really like what I've created here. What we've created here, even though it's been me. But you've been along for the ride. Whether watching it afterward or beforehand, or during.
And now the god of tides is out to end my life.
Imagine Poseidon being after you. Okay, looks like all these speed ones have something extra to them now. Oh, we got another tree right here. Again, all these sight ones, the sight supremacy might die out with this tree about to go out. They're all just gonna die. They're all already dying a little bit. They're just clumped around here, trying to survive. Go, spread the sight. Spread the sight. This is so cool, actually. I really like this. And I like that you can see when they're about to die, too. I'm glad I added that as well. All right. Looks like this tree is gone. Yeah, this turned out pretty dang well, I would say. We got a lot of like big groups of mutations here, like the multi-colored ones, and these guys too. Even another tree right here. Once one grows here, it's gonna start a forest. I just know it. Again, it's like I almost want to have the 100%, or the right now it's still on the 1 in 100 chance, and I almost want to keep that because of how rare it is for a new forest to start. So yeah, we created some keywords with this. Colonies for the colonies of different cells. Forests for the groups of trees that grow. It's kind of cool. Little words that were created just by little phenomenon that we created here. This is neat. I like this. Oh yeah, all the sites that were here ended up dying, but they are kind of living on through what is apparently one last tree. But their site is really helping them. What does site add? It only adds 2 to the site, but that's 2 pixels, and that builds pretty quickly. The speed is the one that probably builds the most, but I think that's worth. Okay. Got another tree over here. Nice. I almost want to have less starting trees. In fact, I'm going to go and put that in while that's still going. Say that we're going to start with 8 trees and only 400 cells. Because a lot die off very fast. In fact, let's bring it down to 100 cells for whatever our next simulation's going to be. And who knows, I might stream a whole just group of simulations that I come back to every now and then. That would be cool. Remembering kitty hearts, as complicated as we are. Oh, another tree right here. So we kind of like a pretty spread out forest.
right. So these guys, these speed reactions, the speed and reaction time, the Sonic the Hedgehog's over here, are gonna have to start migrating out, but the speed helps. Although this tree might keep them alive for a while. I like that these guys are still kind of here with whatever tree was there. If it's still there. I think it's about to die off. I might make it to where the trees die off a little, like you don't see them keep growing fruits even though there's like 2 or 0 pixels left. Yeah, like that tree's probably gone now. That's the last bit of fruit it's gonna make. Oh dang, but it made some pretty cool sight speed combos that are gonna go out and probably spread this way, I would imagine. Yeah, coming out this way. This guy's gonna keep him alive if he turns. Oh, he turned the wrong way. Oh, they might die out. There's the last ones over here. Come on, spread the speed sight. Spread the speed sight. No, there he goes. It looks like the whole colony of speed sights up here has died out. How sad. But we're having there's a lot of mutations going on. Getting some powerful looking cells going about the place. I almost want to go ahead and add in speed blast that it moves 2, but nah, I won't. Like 2/2, so it moves really fast inside the cell. These fruits are just out here. They could grow a new tree. Oh, they did. Come on, another one. Do another one. You can do this. Start a new forest. Start a new forest. Start a new forest. No, don't eat them. Don't eat them. Don't eat them. Okay, well, start a new colony then. Fine. Nice. Look at how fast those colonies start, too. As long as they can eat in succession, they're pretty good. I almost want to add a little less of a threshold so they have to eat, again, really fast. But at the same time, they're doing that anyway, so I'll give them a good chance. I don't want to be that cruel. And then that little last tree is creating a new colony here, too. That's not going to last super long, but, you know. What the? Was he above another one? That's crazy. That one that just died. It would be so cool to make them not be able to collide with each other, because then they're just going to be fighting for the food. Wow, they're all still going. This is really neat. I really like this. I might just mute and let this go on for a bit and then end the stream then. Nah, I'll stay here and not really commentate. I'm, again, not exhausted, but like doing all what I just did certainly took a bit of my brain power out of me. I'm going to go ahead and decrease while I'm here, though. The start mutations are going to be 0, so some of them might start with 0. And we're only going to try mutating 3 times. So that's just for the very beginning. There's a new tree that spawned up there from the randomness. I like how we're still keeping about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, about 10 trees. Okay. All these guys over here. We have a constitution blast again. He's gonna die. Now eat the fruit. Yes. Spawn a new one. Yes. Spread the constitution. Spread the constitution. Yes. Now go out, you long-lived fellows, and spread the constitution across the world. If you have enough, that is. There's a possibility you won't make it. You might. Come on. Yes. Yes, you have 2 extra seconds to live. Come on, go grab the fruit. Go grab the fruit. It's right. Oh, wow, there he goes. Looks like Constitution didn't last there. Is there a Constitution going on that I'm not seeing? Oh, there's another Constitution one here. I think he lived from that little spurt. Some constitution. Ooh, you could start a constitution. Supremacy. But again, constitution kind of like, it doesn't die out quick, but it's not as good as having speed and sight. And the reaction to eat the food fast. Hello. Welcome to the stream, my 0 viewers, but possible future viewers. Joy. So so I did a lot of work here. I created all of the different organelles they can have, which will give them more speed, sight, reaction time, or now I added a new one, constitution, so they get like more time that they can live. So the little blue ones, all the little blue squares that you see going, those are speed plasts. The pink ones are the reaction time. The yellow ones are the sight, the ones that kind of look like eyeballs when they're standing still. And then this thick red ones are the thick orangish red is the constitution plasts. Yes. And so I also added a thing where random trees will spawn, so it'll kind of keep things going. And then fruits can also spawn new trees whenever they die. So it might grow a new tree. But they're eating the fruit, so they don't get the chance to grow. So like one of the cool things I like is that there's a possibility like one spawns here and no cells are around it, and so it starts a whole new forest. And then one cell finds it and just and starts a whole new colony in seconds. These things reproduce fast. Chad face. But yeah, I'm gonna add a thing to where they grow. The actual cell size grows based on how many organelles it has, and I might make them move slower due to that. So like the only ones that can keep up are the speed ones. Like for every extra bit of speed you have, you move, or every extra bit of size, you lose a speed. But every speed class gives you 5 speed. So that might completely change how this thing works. Right now, as you can see, there's not a lot of constitution ones, because it's like what's needed more than constitution is speed and sight and reaction time, just so you can eat the fruit the fastest. Exactly. But like before this, there's one little change I made, which is that spawning the random trees. That one little change made constitution more obsolete. But hopefully some of these ones that have like constitution and speed here might live out. But yeah. Yeah. And if I start a new one, so I changed all the variables quite a bit during that one simulation, but now this should start. So like a lot of empty cells are now created. But right over here you see instead of these empty cells reproducing faster, these reaction ones did because they ate the fruit faster. But I'm probably gonna make a thing. They saw the fruit faster technically. But there's a thing where it only eats the fruit once it sees the fruit. And I want to make it to where if you like accidentally stumble on a fruit, you're like, oh, thank you. Oh my. I'm just wandering around and running into fruit. Alright, so now these guys should eat a few of these fruits. And one of them should mutate at some point. The way a cell reproduces, it has to eat, and then it has to eat again within 4 seconds. Yeah, so you see they're splitting, but right now there's no mutations, so they're all still blank cells. But at some point, like this guy has the chance to mutate right now, nothing. Yeah, those guys were started as non-blank cells. But right now, I'm looking at these guys specifically. These are blank, and I want to see them become not blank. So like this guy right here, he has the chance to start a mutation. Nothing yet. Nothing yet. It's a 1/100 chance. It's a 1% chance to mutate. Happens more often than you think, though. Come on, guys, you can mutate. These two groups right here are what I'm looking at. Although these guys are probably going to take over this one. Come on, maybe they can't mutate if they have 0. That's always possible. Well, no, they should be able to. That's what I want. But I might have done a thing with the way they inherit. Oh no, look! A constitution blast! That mutated. Those are the reaction ones. But this one came from over here, which is, as you can see, is all blank, but there he is. But he's gonna die off because he wandered too far. Poor boy. But yeah, look at all these. These ones are all blank too. Look at them now. They're all sighty. Very sighty, actually. Yeah, this is like the last blank colony there is. And as soon as one of them, again, constitution is good,
it gives you more life, which is a new one. Like from the old one, the Constitution, it didn't exist, so I just made it. Like I thought of it, and I'm like, wait, let's add that, and then I added it really quick. And then there were some weird problems that I thought were problems, but it was just me forgetting how RGB values worked on accident.
That's fair.
I thought one was I confused green for yellow. RYB, Yerb, Reeb. Come on, start a new mutation. Start a new mutated colony. You can do it. You can do it. And you're the one. You're the chosen one. You three are the chosen ones. One of you is the chosen one. I like how it looks like they're splitting too, because one will stay still and then the other one will move away.
Yeah.
I didn't even mean to do that, but it's oh well. The reaction ones took over. All these guys are gonna die off now. Watch. These are cells. They don't bang yet.
I was gonna say I thought so.
Some do, yeah. I could add that too, to where like give that a behavior to where to like find something that has something that would be good and mix with it, and then they'll create one that has both. Because one thing I want to add is like big organ.
You're beneficial.
Your benefit. I want to add behavioral organelles as well. So like one organelle that only has one. When you have it, you have it. You don't get like two of them, but it changes the way the cell functions. So like one where it specifically goes out to explore more, or one where it'll always stay around a tree, no matter what. It'll never wander out, or one that will eat other cells. And then one that will specifically run away from other cells that are trying to eat it. It's like,
It's so new. Why are you introducing cannibalism?
because cannibalism is fun? I mean, not for me specifically.
Why are you
For,
saying that loud?
well, with that, I think we should end this stream. No, I was thinking about ending it anyway. This is cool. I might do a stream sometime, like I said, where I'll just run a simulation just with some music and just keep running them. And so there's like, it's logged for eternity. See, look, this might start a forest now. I actually want to see this. Yeah, that was one of the random ones. So it will randomly grow one every 60 seconds. But these have a chance. I think right now it's a 1 in 200 chance every time a fruit dies. See, because they're disappearing on their own. Every time one dies, it will have a chance to grow a new tree. So as long as this guy doesn't come over here, as long as these guys don't come over here and eat all the fruits.
They're doing
There, he's gonna come over and eat all the fruits.
Oh.
Maybe not. This guy is not. Come on, start a forest. Start a forest.
I think you're scaring them away with your nose.
Yeah, I do want to make a thing where I can click on them and then it like prints something to the console, so I can see the info of the cell. Come on. Maybe it's not often enough. Maybe.
Let's go.
Boom. Unless that was just like happened to be one of the random ones. Did you see that guy die right as he got there?
That's so sad. I thought I saw a fruit there.
There was.
Yeah, and so I was like, I don't think it's
Yes.
random.
I don't think it was. Come on. Grow more trees. And then one guy's gonna find it and just.
Oh, getting close.
Well, this guy might. Nope.
Extinct.
I think I like the 1 in 100 chance for fruits. So like forests will just spring up as soon as there's a random tree that spawns somewhere. Come on. You know you can do it. The little fruits. You're not even sentient, but I believe in you. For you are my creation. Oh. Oh, here we go. New colony. Sight and reaction. And whatever else they mutate while they're eating. Boom. And now they're going to get to this little group and just boom, 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 boom. Immediately populate the whole area. Just in an instant. Literally rabbits. Widowy wabbits. Yep, there we go. Reaction in sight. Yep, a colony right there. Alright, I'm gonna go and change this to 100 again. A 1 in 100 chance. Hell, 2% chance. We're crazy like that. And there we go. So we'll continue back. We're gonna change the way, we're gonna make it to where it changes the size of the cell. We will, I mean, I guess just optimize some stuff like that. I know I have a couple other little ideas. I forget what they are already. That's crazy. I mean, I do have a bunch of to-dos. Let's see. We'll change the sizes of them. This is just a thing I'm going to figure out on my own. And then make sure that they just, when they run into a fruit, they eat it. That it's outside of their attempts to eat it. And yeah. So that's where we'll continue next time. Until then, farewell.